Chapter 2, Lesson 6 of Advanced Algebra, we're going to look at families of functions. And a family function, or a family of functions, is simply where we take a parent function and then we move that graph right or left, or maybe we stretch it and shrink it, or maybe we reflect it, make it go upside down, which we noticed a little bit that we can do with absolute values when we have that negative sign in front. So we're going to look at how these different functions, how the equation is affected, and then how that changes the graph and where it's located in the coordinate plane. So we're going to look at translations, we're going to look at stretches, shrinks, and then reflections, and then we'll summarize everything, because the summary is going to be very important, because everything that we learn in this lesson with absolute value functions is going to apply to every other function that we look at the rest of the year. And this is going to be kind of the scenario, or how we take a look at these functions as we go throughout the year. We're going to do what we did with absolute value functions. We're going to look at the parent equation. We're going to look at the vertex and how to calculate that algebraically. We'll look at how to graph it with a table and with our calculator. And then we'll want to look at how do we change that graph of the parent function by translating it, by stretching it, by shrinking it, and how that affects the equation. And how it affects the equation is going to be the same for every function that we look at. So understanding it now, we'll lay the foundation, and then we'll again use this throughout the year for every function that we look at. Now, there is a activity that I would like you to do on your calculator. If you go to page 93, and I'd like you to do this exercise. So just go ahead and stop the video and do this exercise here, and see how these different numbers affect the graph as you see it. In other words, we have the absolute value of the function, that's the parent. Then you add a +2 on the outside. What does that do to the graph? What does a +4 on the outside do? And what does a -2? And then go back and look at the absolute value of the parent function, and then add the 2 on the inside, or the 4, or the -2, all on the inside of the absolute value. And then put a number in front. What does that do? And then put a negative sign in front. What does that do? So do that, get a picture of how that works on your calculator, and then come back and we'll talk about this in the rest of the video. So if you've looked at that, we'll talk about families of functions, and these are functions that have common characteristics. We have the parent function, which is the simplest form of the equation. So we talked about y equals the absolute value of x being the simplest form. That's the parent. And then every other equation in the family is simply a translation or a shift of the parent function. We can move it to the right or left, meaning horizontally, or we can move it vertically, or we can do both, horizontal and vertically. We can also stretch and shrink, but we'll talk about that in another video. We want to concentrate on these horizontal and vertical shifts in this video. So we have our parent function, y equals the absolute value of x, and I'm going to bring up a visual here. So this is f of x is equal to the absolute value of x, and so this is what that looks like. And this is the parent. You'll notice the vertex here is at 0, 0, or the origin. These rays here have a slope of 1 on both sides. One is -1, one is 1. And that is the parent function. Nothing's changed. However, we can change that. If we move the graph up, you'll notice that the equation, and which you hopefully saw in your activity that you did, when you added a number on the outside of the absolute value, it moved that graph up or down. So you'll notice if I add a number on the outside of the absolute value equation, you'll notice a positive number moves it up, and a negative number moves it down from the parent. So we start with the vertex at 0, 0, that's the parent, and then a negative value moves it down, and a positive value moves it up. So the number that you see on the outside is the vertical shift of the parent function, either up or down. Notice it doesn't change the slope of the rays, it doesn't change the shape, it simply moves that vertex point up or down those values. So a number on the outside is a vertical shift. Now if we change the number on the inside, that's going to move the graph right or left. Now I want you to notice how I move it right or left, but then also notice how the equation changes. So notice a negative number moves it to the right, or the positive direction, and a positive number inside moves it to the left are the negative. So on the inside, the number that you see, that's the shift is the opposite direction of what you see. So a negative number moves it to the right in the positive direction. A positive number moves it left in the negative direction. Okay, but on the outside, a negative number moves it down. So the negative number moves it in the negative direction, and the positive number moves it in the positive direction. So it's very important that you make sure you know the difference between those two. And in pre-calculus next year, we'll talk about why it works that way. And I'm not going to go into a long explanation right now. I might reference it in future videos, but really what I need you to do is just kind of memorize that. So if it's a vertical shift, the number on the outside, the positive number moves it up, a negative number moves it down. However, when you're talking about a horizontal shift on the inside, a negative value moves it in the positive direction, and a positive number moves it in the negative direction. Okay, so these are all the same function, and so in order to kind of put a number or an equation together, we in mathematics call horizontal shifts H, and we call vertical shifts K. And again, H and K you're going to see for the rest of the year, because all of these shifts that we're talking about will apply to every other function that we look at. So if we look up here at this equation, then a vertical shift is going to show up as a plus or minus K, and K is just the number on the outside. The horizontal shift is going to show up on the inside of the absolute value, and that's going to be H. So again, H and K, we're going to see that all year long, because we're going to continue to use horizontal shifts and vertical shifts when we're looking at these families of functions. So very quickly then, an absolute value equation would look like this, where H is the horizontal shift and K is the vertical shift. So what that does is it shifts every point to the H that far and every point to the K. And we're most interested in the vertex. So with the parent function, we start with the vertex at 0, 0. So this number will move that vertex to the right or left H units, and this number will move the vertex up or down K units. So actually, by looking at the equation, we can locate the vertex very quickly without having to do that opposite of b over m that we were doing in the earlier lesson. So HK will give me the vertex. So all I will need to do then to graph is to look at the equation. I need to determine the location of the vertex. So I simply start at the origin, 0, 0, where the parent vertex would be. I go to the left or right, H, and up or down, K, and graph my vertex. And then from the vertex, the rays have a slope of 1. And we'll look at other values that will change the slope later, but for right now, we're only looking at horizontal and vertical shifts. All right, so I'll do one example, and then I'll do another video where I'll do a number of examples so you can check that out. Here's our example, y equals the absolute value of x minus 4 plus 3. So the first thing I want to do is locate the vertex. So again, I can use the shifts to locate where my vertex will be. So on the inside, the number that's next to the x is this horizontal shift, the x-axis. And again, it's the opposite shift of what I see. So I see a negative 4 here, so my shift is going to be a positive 4. On the outside is the shift up or down, so this is going to be a shift up 3. So remember, the horizontal shift is the opposite number that I see. The vertical shift is the number that I see. So my vertex is going to be at 4, 3. So I'll go to my graph, I'll make sure I label this, and I'll make sure I put my scale on there. And now the parent has its vertex at 0, 0, so I'll start there, but the shift of the vertex is now at 4, 3. So I'm going to go over 4 and up 3, and then that's my vertex. So again, I want to label that 4, 3. Now it's a positive absolute value, so that rays open 1, up, and they're going to have a slope of 1. So I'm going to go up 1 over 1 for that ray, and I'm going to go up 1 over 1 for this ray. So now I have my vertex and I have the slope of the ray, so I'm going to go ahead and draw this. Let me try that again, because that didn't quite work the way I wanted it to. There we go. So that's going to work here and here. So using the vertex, I can very quickly graph the absolute value using the shifts rather than going through the process of finding the linear equations or making a table. So here's my vertex 4, 3. The shift is 4 and 3, and I can graph very quickly this function, which is a shift of the parent over 4 and up 3.